In this lecture, we are going to study about the different methods of the analysis of trusses. Here is the first method, that is the method of joint. The truss is made up of numbers of single bars which are either in compression, tension or no load. The method of joint uses the summation of forces at a joint to solve the force in the member. In this method, we used the FBD of entire truss. Then applying the conditions of equilibrium, find out the support reactions. Then consider individual joints, draw the FBD of that individual joints. Then same procedure, apply the conditions of equilibrium and find out the unknown forces in the member. In this method, we does not use the moment equilibrium equation, that is summation of moment is equal to 0. This is all about the method of joint. Now the steps in the method of joint. First step is that draw the FBD of entire truss, apply the conditions of equilibrium, find out the support reactions. Then second step, consider any joint, draw the FBD of that joint, then apply the conditions of equilibrium, that is summation fx equal to 0 and summation fy is equal to 0, and find out the unknown forces in the members. Now we will see our numerical depend on the method of joint. Now the numerical is that determine the forces in the members in the following truss by using the method of joint. Here the given truss is ABC having span 4 meter and height 1.5 meter. There are two external forces, 8 kilonewton at B and 12 kilonewton at D. Now first step is that we have to draw the FBD of entire truss like this. So see this figure, this is the FBD of entire truss. Means at A there is a hinge support which is converted into two support reactions HA and VA. At C there is a roller support which is converted into one reaction RC perpendicular to the support. Applying conditions of equilibrium to the FBD of entire truss, first of all we apply the condition, that is moment about point A is equal to 0, which gives RC into 4 minus 12 into 2 minus 8 into 1.5 is equal to 0. From this equation we get the value of RC which is equal to 9 kilonewton in upward direction. Then apply the another condition of equilibrium which is summation fx equal to 0, which gives 8 plus HA is equal to 0. Then HA is equal to minus 8 kilonewton, means the consider nature of the force is tension, but the exact nature of the force is the compression. Hence the HA is equal to 8 kilonewton in leftward direction. Now applying the last condition, summation Fy is equal to 0, which gives VA minus 12 plus RC is equal to 0. So VA is equal to 12 minus 9 is equal to 3 kilonewton in upward direction. Then according to geometry we have to find out the angle theta for the further calculation. Hence tan theta is equal to 1.5 by 2 is equal to 0.75, and from this we get the value of theta, that is 36.9 degree. From this sin theta is equal to 0.6 and cos theta is equal to 0.8. Now consider the first joint, that is joint A. Draw the FBD of joint A like this and apply the conditions of equilibrium to the joint A. Applying the first condition, which is summation Fy is equal to 0, we get FAB sin theta plus 3 is equal to 0. From this we get the value of force in member AB is equal to 5 kilonewton and nature of the force is compression. Why compression? Because we get the value as a negative, means consider nature of the force in AB is incorrect, means the nature of force in AB is compression. Now apply the another conditions of equilibrium, that is summation Fx equal to 0. We get the equation FAD plus FAB cos theta minus 8 is equal to 0. Putting the value of FAB, we get the value of FAD is equal to 12 kilonewton and nature of force in member AD is tension. After that, consider the joint C and draw the FBD of joint C. See this figure, this is the FBD of joint C. Then apply same conditions of equilibrium. First condition, applying summation Fy is equal to 0, which gives 9 plus FCB sin theta is equal to 0. From this equation, we get the value of FCB is equal to 15 kilonewton and nature of the force in member CB is compression. Then apply the another condition, that is summation Fx equal to 0, which get minus CD minus CB sin theta is equal to 0. Putting the value of CB, you will get the value of FCD is equal to 12 kilonewton and nature of the force is tension. Now the next is the consider joint D. Draw the FBD of joint D, which is as shown in figure, in which there are 4 forces meeting at a joint D and form a 2 pair of collinear forces. That means in this figure DA and DC form collinear forces, means having same magnitude but in opposite direction. Same applicable for the external force 12 kilonewton and force in member DB. Hence, the force in member DB is equal to 12 kilonewton and nature is tension. From this figure, we get FDA is equal to FDC is equal to 12 kilonewton and nature of the force is 12 kilonewton. FDB is equal to 12 kilonewton, which is external force, and the force in member DB is equal to 12 kilonewton and nature of that force is tension. So this is the analysis of truss by using the method of joint. Now after that, we have to tabulate the result. Serial number, then members, magnitude of forces in that member and nature. So first member is the AB and magnitude is 5 kilonewton and nature is compression. Second member is the AD. Magnitude of force in AD is 12 kilonewton and nature is tension. Then third member is the BC, having magnitude 15 kilonewton and nature is compression. Fourth member is the CD, having magnitude 12 kilonewton and nature is the tension. And last member is fifth one, that is BD, having magnitude 12 kilonewton and nature is tension. So this is all about the analysis of truss by using the method of joint.